My name is Benedict Rayray from BSIT2C. In this video, I'll be discussing about memory management, the memory requirements for computer system, and the role of memory in computer system and operating system. So, first, what is memory management? Memory management is a form of resource management applied to computer memory. The essential requirement of memory management is to provide ways dynamically allocate portions of memory to programs at their request and free it for reuse when no longer needed. Memory management is the process of controlling and coordinating computer memory, assigning portions called block to various running programs to optimize overall system performance. Memory management resides in hardware, in the OS or the operating system, and in programs and applications. In hardware, memory management involves components that physically store data such as RAM or the random access memory, chips, memory cakes, and flash-based SSDs, solid-state drives in the operating system. Memory management involves the allocation and constant reallocation of specific memory blocks to individual ensures the availability of adequate memory for the objects and data structures of each running program at all times. Application memory management combines two related tasks known as allocation and recycling. When the program requests a block of memory, a part of the memory manager called the allocator assigns the block to the program. When a program no longer needs the data in previously allocated memory blocks, those blocks become available for reassignment. These tasks can be done manually by the programmer or automatically by the memory manager. And next is we classify memory requirements for computer systems. When it comes to adding system memory requirements, the general rule of thumb is the more the better. On average, doubling the amount of memory in your system will give you sample space to work and will make an obvious difference in overall speed. This is especially true with today's memory-hungry applications such as office programs, multimedia, editing packages, and graphics-intensive games for which more RAM is needed. Memory allows you to run more programs at once, and our favorite programs will be easier to use. But how much memory RAM does your computer actually need? So, for example, if this is how you use your computer, like you are a casual user, like internet browsing, email, listening to music, or watching videos, the RAM at least 4 GB. For if you're intermediate user, You use internet browsing, email, word processing, spreadsheets, running simple graphics programs, flash games, music, videos, or multitasking. Your RAM must at least 8 gig. And if you are a professional user or gamer or a graphic designer, so it needs high performance gaming, multimedia editing, high definition video, graphic design, 3D modeling, intensive multitasking. Your computer must have at least 32 GB RAM. Next, in the operating system, for Microsoft Windows 10, 64-bit, 2 gigabytes to 8 gigabytes. That's the minimum requirements. For Adobe Windows 10, 32-bit, 1 gigabyte to 3 gigabyte. For Adobe Windows 8, 64-bit, 2 gigabyte to 8 gigabyte. For Adobe Windows 8, 32-bit, 1 gigabyte to 3 gigabyte. For Adobe Windows 7, 64-bit, 2 gigabyte to 8 gigabyte. For Adobe Windows 7, 32-bit, 1 gigabyte to 3 gigabyte. For Mac operating system, for Mac OS X Series, 4 gigabyte to 8 gigabyte. For Mac OS XL Capitan, 2 gigabyte to 8 gigabyte. For Mac OS X Yosemite, 2 gigabyte to 8 gigabyte. For Mac OS XL Mavericks, 2 gigabyte to 8 gigabyte. For Mac OS X High Series, 2 gigabyte to 8 gigabyte. For Mac OS X, 2 gigabyte to 8 gigabyte. Next is the role of memory in computer system and operating system. So first, what is the role of memory in computer system? People in the computer industry commonly use the term memory to refer to RAM, or the random access memory. A computer uses RAM to hold temporary instructions and data needed to complete tasks. This enables the computer's CPU, or the central processing unit, to access instruction and data stored in memory very quickly. A good example of this is when the CPU loads an application program, such as a word processing or page layout program, into memory, thereby allowing the application program to work as quickly and efficiently as possible. In practical terms, having the program loaded into memory means you can get work done more quickly with less time spent waiting for the computer to perform tasks. The process begins when you enter a command from your keyboard. The CPU interprets the command and instructs the hard drive to load the command or program into memory. Once the data is loaded into memory, the CPU is able to access it much more quickly than if it had to retrieve it from the hard drive. This process of putting things, the CPU needs a place where it can get at them more quickly is similar to placing various electronic files and documents. You're using the computer into single file, folder, or directory. By doing so, you keep all the files you need handy and avoid searching in several places every time you need them. Memory is an essential component of a computer. So basically, memory lets you do everything much faster. If you have like 16 GB of memory, then your PC will boot faster. Your applications will launch faster, and your computer paired with the right processor will be able to run servers. With 4 GB, everything will be slower. Servers will be unstable and programs will crash more often. Role of memory in operating system. Memory management is the functionality of an operating system which handles or manages primary memory and moves processes back and forth between main memory and disks during execution. Memory management keeps track of each and every memory location, regardless of either it is allocated to some process or it is free. It checks how much memory is to be allocated to processes. It decides which process will get memory at what time. It tracks whenever some memory gets freed or unallocated, and correspondingly it updated the status. So, it is the most important function of an operating system that manages primary memory. It helps processes to move back and forward between the main memory. So, it helps also the operating system to keep track of every memory location, irrespective of whether it is allocated to some process or it remains free.